Altair SimLab allows to define mesh controls on the geometry in order to achieve locally the desired density and structure of the mesh. Users can create a mesh template containing all mesh controls corresponding to their meshing guidelines, so that every time they only have to import the template and assign the mesh controls to the different geometry entities. For the meshing of this differential housing, we import a template containing 7 mesh controls. We will assign them manually, but we will see how the assignment can also be done automatically if we adopt a color or a name convention on the geometry entities. SimLab can easily search for geometric features like cylindrical holes, fillets, cones, hollow disks, and many more to speed up the selection of the entities. Of course, also additional mesh control can be easily created. For example, we can request a particular mesh structure for these bushing faces. Further mesh controls are available. For example, you can break a body with a plane or a cylinder while meshing, or require specific mesh patterns. Once the mesh control are assigned, the surface mesh can be generated. If for any reason you are not fully satisfied with the result, It is not always necessary to go back to the CAD and edit the mesh controls. In most cases, it is possible to remesh or modify directly the surface mesh before creating the solid elements. SimLab transfers all information about shape and topology of the CAD geometry to the mesh bodies. Shell elements are grouped into FE faces, which can be handled simply like you would do with CAD faces. Without touching the CAD, you can manipulate the FE bodies and see in real time how the modifications affect the elements. We show on this model typical examples of modification or suppression of features and of local mesh refinement. Before creating the solid mesh, we can still require, globally or locally, a minimum number of elements through the thin walls. In our example, we define a minimum of 2 tetrahedron layers on the walls surrounding the bolted joints. After the generation of the solid elements, we verify that the layers were created only where requested, reducing the model size. The element quality can be checked and cleaned up automatically. Both geometrical and solver-specific criteria are available. The meshing process is completed. We can export now the mesh settings as a mesh template to reuse them in our next simulation. If we adopted a color or a name convention, we can assign automatically the mesh controls to another model. In our example, we could use the names of face and edge groups as a reference for the mesh template. Colors and groups can be defined both in SimLab or in the CAD environment. In the next video, we will show you how to complete the simulation setup with Altair SimLab, defining bolt connections, contacts, boundary conditions and load cases, in order to run the analysis directly in SimLab using Altair OptiStruct or any other solver.